everyone, and welcome to Chem Talk, where today we'll discuss the influences on reaction rates and how chemists use this to make medicines more efficient. So let's talk about it. First of all, what is reaction rate? Reaction rate measures how fast or slow a chemical reaction occurs. Certain factors can impact the reaction rate. In this lesson, we'll examine the effect of temperature, concentration, surface area, and catalysts on reaction rate. So when we use temperature to manipulate a reaction, we heat up or cool down the reactants. When particles are heated up, they move faster, and when they're cooled down, they move slower. So what's the effect of this? Well, think about it this way. If you were walking down the street and everyone else was running around, you'd be very likely to collide with someone. Whereas if everyone was moving slowly down that street, collisions would be less probable. This is the same way with reaction rate. Since increasing temperature causes particles to move faster, they are more likely to collide with other particles, making the reaction occur faster because reactions result from particle collision. And because decreasing temperature causes particles to move slower, collision between particles is less likely, thus slowing down the reaction rate. Now, how does concentration affect reaction rate? Let's use another analogy. Say you're at the mall and it's super crowded. It's very likely that you'll bump into people there because there are just too many people. But if you're at a mall when it's less crowded, you probably won't collide with anyone because there aren't enough people to bump into. This is very similar to how concentration affects reaction rate. When concentration is increased, there are more particles being reacted, making it much more likely for them to collide and thus speeding up the reaction. And when concentration is decreased, less particles are there for them to collide with each other, so the reaction rate will be slower. Alright, so now let's talk about surface area, which is just the area of an exposed surface. If you're somewhere like the park and you're walking with your friends who are all around you, the likelihood of you colliding with someone would be pretty low, because only the friends on the outside of the group, the ones surrounding you, will collide with people because they are exposed. But if your group splits up and each friend is walking alone, the probability of you colliding into someone is higher, because now each of you have an exposed surface. The same thing goes for chemical reactions. When a substance has less surface area, it is less likely to collide with other particles, which will result in a slower reaction. But if we increase the surface area of a substance, the substance has more exposed surfaces and will collide more, resulting in a faster reaction rate. For example, if you want to use a tablet for some reaction, and you have a whole tablet and one that's crushed up, which one should you use for a faster reaction? Well, you would use the crushed up tablet because it has a greater surface area since more surfaces of the tablet are exposed. And finally, we have catalysts. A catalyst is a substance that chemists add to a reaction to speed it up, but the catalyst itself won't get consumed in the reaction. Think of catalysts as party planners. Party planners are hired to set up the parties that bring people together, but the planners themselves are not guests at the parties. This is similar to how catalysts bring particles together and cause them to collide, but they're not actually reacting themselves. So here on the screen are some practice problems for you to try out. In the description box down below, an answer key for these problems is attached, so be sure to check your answers with that resource. Now, let's discuss why these influences on reaction rate really matter. Well, understanding these influences has helped chemists make medicines function faster. For example, a catalyst is used on an antibiotic called cefprozil, a medicine that's mainly used to treat respiratory tract infections. Chemists use enzyme catalysis on this antibiotic as an environmentally conscious way of making the medicine work faster and produce a greater yield. In addition, in a study of healthy adult volunteers, the volunteers all took paracetamol, a drug that's used to treat minor pains, and some took this drug after drinking a hot liquid. The study revealed that paracetamol absorption was much faster and higher in those who took the drug after ingesting a hot drink. So this highlights how temperature was manipulated to make a medicine work faster. So before you go, let's recap what we covered in today's lesson. Reaction rate measures the speed at which a reaction occurs. Increasing the temperature, concentration, or surface area of a reaction, or adding a catalyst, will increase the reaction rate. And people use these influences to make reactions work faster, such as the use of enzyme catalysis on cefprozil or drinking something hot before taking medicine. And that is it for today's video. Thank you so much for tuning in, and be sure to visit our website at www.chemistrytalk.org to access more amazing chemistry content. Bye!